Hi, I'm Melanie. This is Chad. We are here today. We're going to talk to you about open source. We're going to talk to you about Temporal. Chad has been here for a very long time, and well, you've been here for a little while. You have an expertise around the space. You have an expertise around Temporal, and especially around open source. I'm thrilled that you're here. I'm thrilled that we're both here to be able to talk about it. And yeah, thanks everybody who's in the live stream watching and seeing as we actually literally are live. Chad, can you do a quick introduction of yourself?
Sure. So my name's Chad. I work at Temporal. I've been here well over 4 years, and I've written a lot of open source code at Temporal, especially around the SDKs in several different languages. Happy to be here.
Glad you're here. Yeah, now I've got chat open. We're going to keep an eye on it. If you have specific questions, please feel free to jump in there. But the reason why we're doing this today is because, or the reason why we're specifically talking with you, Chad, today is because you do have such a love and passion for open source, because Temporal is open source. Can you tell us why it matters so much to Temporal to be an open source product?
Sure. So, well, it matters both to me and to Temporal for different reasons. It matters to Temporal for a lot of trust reasons and visibility and transparency reasons. You can't reasonably build a dev platform without being open source and being open to the community, and not just performative open source, but literal MIT license, full thing open source. And as for myself, it's important that it's open source because I appreciate working out in the open. I appreciate the transparency of open source. As I go on in my career, I appreciate that my code isn't hidden somewhere behind some closed door. So there's lots of benefits for both me and Temporal that it's open source.
And in essence, at the end of the day, people can run this. They don't have to pay any money. They literally can just go get it and run it.
Yeah. I mean, that's important. Nobody likes to be locked in.
No, you're not locked in. So, what I've got currently showing up on the screen is the fact that, like, if you want to go check out the repo, it's out there. I know we were talking before about the fact that Temporal has a server, and that's its main the main kind of home base of all the code in some way, shape, or form. But then on top of that, it has its SDKs. And we were going to dive into the SDKs in particular. Do you want to explain a little bit about the difference, and then we can dive into code?
Sure. So our server is a large Go project in Go repo that effectively handles persistence and task distribution and event management for workflows and activities and other parts of the Temporal ecosystem. The SDKs are what make all of your code run and turn it to these events and commands. So both are pretty complex in their own way and work together symbiotically to make it look like a seamless experience from regular code to durable code.
Love it. Yeah, Chad, do you want to show us how a workflow works within the Python SDK? I know you were thinking about that as an option. And while you're bringing that up, again, we got chat open. So, like, if y'all have any specific questions or things you want to see as we're doing this, please feel free to jump in. And also curious to see where people are watching from, if you want to share in the chat.
So I have VS Code opened here in a big monstrous folder where I check out like all the Temporal repos. I just find that that's easier when doing these types of things where we walk over code and demonstrate some code. Also makes Claude happier if it has to do some work. So what I was thinking about doing today is I was basically thinking about just showing, we'll keep it fairly high level because we don't have infinite time, but just kind of showing what happens, at least from the SDK perspectives, or at least the language part of the SDK, maybe not as much the Rust core part, of what happens when you call a workflow from a client and how it ends up executing your code. So let's say, so we're going to choose Python because it's pretty popular these days for obvious reasons. And so let's say like you're in a basic sample and you have a workflow that looks like this. And the workflow is, decorated as a workflow, and it has this run call and it executes an activity. So when you do this in Temporal, as everybody that's watching is surely aware, you have a worker and that runs on some machine or several machines that runs the actual workflow code. And then you have a concept of clients, and clients are what actually kick off the thing and maybe wait on a result. So this client call is an execute workflow call that effectively tells the server to start it, and then it sits and waits on the result from the server. So the way that actually works is inside the Python SDK, and the same goes with all SDKs, though every SDK has its own differences and is very idiomatic to the language. Therefore, all the details aren't the same, but from the outside, it's mostly the same. So inside the SDK, we have several different modules and several different parts of the SDK, but the SDKs are, for the most part, two things. They're clients and they're workers. And they're rarely ever even in the same commonly used for the same things in the same process. But from a client perspective, let's say that you're starting a workflow or something. And so we have inside our client, our big client class, a start workflow call. And you'll see all the overloads here because we have extreme type safety at Python. So, and at Temporal. So you'll see all these overloads, but they effectively distill down to this common signature. And we take a few required things, the workflow, the arguments, the ID, and the task queue. Everything else is optional, but it can get complex. And I won't go into all of it. But and ignoring the docs, the code is actually kind of small because what it does is it effectively delegates to what we call interceptors. Interceptors are arbitrary things users can write to intercept a lot of things that happen inside of Temporal, including starting a workflow. So you'll see like this, this just delegates the same thing to this start workflow call on impl, and this is just an interceptor. It's effectively, interceptors effectively wrap everything, as you may be familiar with, like gRPC interceptors or something like that. And we create this big input data class and we send it to this interceptor. So we obviously have the actual implementation as like a root interceptor. So let's hunt that down. That looks like, okay, so this is like the lowest level interceptor where you land after all the other interceptors, which there are no interceptors by default. So where you land by default. And you can see we effectively build up a gRPC request. So when, to take a quick aside, when you make a, let's see if I can pull this up here. So when you make a workflow call, you're effectively making a gRPC call to our Temporal server. And it just makes a start workflow execution call for starting a workflow like this. And it has a big, let's see. So it has a big request that's like this, and it has all the details, and most users don't have to worry about these details, but we effectively translate to these details and do all the serialization and setting all the values and handling all the retries and things like that to make a start workflow invocation. So that's essentially what this does, is it just builds a big, and I know that I'm jumping around quick. I'm not expecting you to read the code, just kind of understand what's happening.
Oh no, we're going to test everyone after this.
Yeah, right. Anyways, it builds a big, just builds this big start workflow request. We set the namespace and we serialize the payloads with the converters, all the basic things, though they're actually not that basic. It's pretty complex, even the serialization mechanism, but I'm not going to get into all that. So anyways, you build this big request and it sends it off to the workflow service. So if it's signal start, but otherwise sends off just a regular start workflow call. And then it sends back a handle where you can pull for the result, and the execute shortcut that we're doing at, let's see, do I still have that sample open? That we're doing in that sample, the execute shortcut is basically just calling start and then waiting on the result. We'll get back to the sample later. So effectively what happens is that goes up to the server, and I won't get into the server code, but the server persists that on a task queue and effectively gives that to any workers that are pulling on that task queue for that workflow work. So that's done via a workflow worker. And we have all of our newer SDKs are backed by a common Rust core because we recognized as we started to build these complex state machines in the SDKs across different languages, it was unreasonable to re-implement the same state machines and same logic in all the different languages. So Python actually uses a C extension based in Rust. It uses Pyo3 library to effectively bridge it. But basically,
but the core is the way we and basically plug back into the server. And you were saying like the reason why we have so much functionality in this SDK is because the reason why so much functionality is baked into the SDK. Why is that?
Oh, because, well, in general, the SDKs have to be smart because they're the only ones that can translate user code into these deterministic set of events. Every language has different forms of user codes, and how to translate, cooperative coroutines deterministically with certain calls and specific to that SDK into events is very language specific. The server doesn't know or even care what language you're running, nor should it. It only knows, hey, I want to sleep. Hey, I want to start an activity, things like that. How that relates to what looks like loops and conditionals and all these, which actually are loops and conditionals and exceptions and all the other language machinations, is very much the product of the SDK. So that's where a significant amount of complexity lies, taking your traditional imperative code and turning it to a deterministic set of commands and events that can then be automatically replayed on another machine, say if it crashes, hence turning your code durable. And that's why the SDKs have to be so smart and so in-depth.
That.
Sure.
I do have some questions that are coming up that are specifically, and Mike Sherman, I know you're one of our main community members that are out there. You're asking about like explaining workflow to namespace relationship, and also asking about shouldn't you be checking for response equals null? He was asking though, are you checking a specific class of exception like RPC error?
Yeah, so we can get into details, but I'll give it at a high level. So first of all, namespaces are the overarching hierarchy that is present at Temporal. You don't usually cross namespaces. There are things like Nexus and such, but namespaces can effectively be the collection of all things run within them, workflows and activities and stuff. So, and especially if you're a cloud user, you'll be well familiar with the boundary that is the namespace. But that is our primary top level hierarchical unit for the open source server.
He said he appreciated the high level. Yeah.
I'm sorry?
He said he appreciated the high level, and we appreciate the question, Mike.
Sure. And then as for like specific exceptions and errors that we check, yeah, so obviously if an error comes back from an RPC call, you either handle it or you're going to rebubble it most of the time. Sometimes we implicitly retry it. I could spend hours explaining our retry logic based on gRPC codes that are transient versus non-transient and the backoffs that we apply and how we sometimes convert RPC errors to traditional Python errors and extract out gRPC status details. There's a lot that goes in it, but suffice to say, there's the SDK handles all of that error management. And from a user perspective, you will just see like a workflow start failure of a certain form or an RPC error of a certain form if it doesn't reasonably translate to a higher level error.
Thank you.
Sure. So going a little bit through the worker side. So this is like the Rust code that is on the Python side where we basically just pull for work, and we're just pulling the Rust core for work. It's just basic Tokyo async if you're familiar with Rust. So what happens is we pull this and it comes back as effectively a protobuf. So the protobuf, we translate what we call workflow tasks, which are the individual units that drive workflow execution. So workflows are run for weeks, but tasks run for like milliseconds. They're essentially like, do the next thing, do the next thing, do the next thing. That's how workflows are driven. And our Rust core turns those into activations. Most of the time they're one-to-one with tasks, but sometimes not when local activities and queries and stuff are involved. But basically an activation comes over from the Rust core and effectively from the server with workflow tasks with a set of work or a set of events that has happened. And you see these same events in history, right? And so the start workflow will come with the initialize, maybe if a timer is complete or an activity is complete, what have you, right? Well, it is the responsibility of the SDK languages to handle these and turn these into reactions to your code specifically. So we have a concept of a workflow worker. And a workflow worker, it has a polling loop. And this is how Temporal works. It's this nice little tight loop. Give me work, run it in the background, create tests. Give me some more work, run it in the background. Of course, all this is bound by concurrency limits and rate limits and things like that. And then we go and handle the activation. And the handling the activation is a pretty complex process. Ignoring some of the sticky and cache stuff, and I can explain some of that here in just a second, we basically just, and some of the codex stuff, we basically just ask each workflow to handle its own activation after instantiating it. So that brings us to, and so we effectively call the workflow activate inside of a threaded executor. That's for deadlock detection. I could explain that. But basically, you have this behemoth here, and this is a workflow instance. Workflow instance represents a workflow. If the machine crashes, this is the thing that we're rebuilding when we are resuming it on another machine. It has all the state that is tied to the actual user workflow code for an individual workflow running. But the interesting aspect for our different SDKs is that they are also coroutine schedulers. So like, it's not an accident that this extends async IO event loop. It is an async IO event loop. So we set a lot of stuff up, but this is the main entry point for each tick, if you will, of the workflow. It is activate. It is an activation. It accepts this activation, and it goes over the jobs that it has to do. It does a couple of special things with regards to ordering and whether it's doing like signals or updates or whatever, but it runs the jobs. It effectively applies the job. So if you got a timer complete, we'll complete an async IO future. If you got an activity complete, we'll deserialize instead of that. And then it ticks the event loop. And ticking the event loop is basically saying run until all the coroutines are yielded, and collecting all the commands that happen in the meantime. Commands are things that the workflow is asking the server to do. So for instance, we saw in our sample, let's go back to that guy. We saw in our sample that our workflow is executing an activity. Executing an activity is the shortcut for starting an activity and waiting on the result. Starting an activity, scheduling an activity, however you want to say it, is effectively a command to the server. So we send, and then it literally is over gRPC, hey, these are the commands that the workflow wants to run. The server does run them by scheduling the activity. So you can see the commands if curious in our same API as you'd see anything else. And so like, here's a command, and it's any of these types of things. Really, there's not that many things a workflow can do, believe it or not. You can schedule an activity, you can start a timer, you can cancel other workflows, cancel timers. So we send these commands up, and these become events in what you see in history. And then the server may run the activity, and there's activity workers, and I won't get too into detail, but suffice to say, they take a single task, they run the activity, they send the result. And then the server will relay via the next workflow task and workflow activation. This activity is now done, at which point we will, if it's already in cache, reuse this instance with the next job for like resolving an activity. And you can see all the different jobs here and how they apply. So it would do something like resolve the activity, which, will find the pending activity and set its success or failure, or whether it was canceled or backed off or whatever. And then that will end up resolving the future from the user. So the user just magically sees, oh, this was completed a week later. And they don't know that really we actually remade this whole thing on a whole nother machine, replayed it up to that point, gave the solution, populated the future and sent it back. So in a nutshell, that's kind of how the workflows work. Now, there are lots of details on serialization, concurrency, what the Rust side does, how pollers work, how activity workers work, how especially around workflow caching and sticky caching, which is our optimization to make those successive tasks go back to the same worker each time, so that this monstrous object I'm talking about doesn't have to get rebuilt and replayed every time. But in a nutshell, that's how it works from a purely SDK perspective.
We actually, that was really great. We had two questions that came up, and I'm actually going to touch on the first one from MT Rizzi, which was, how can people contribute to this?
Yeah, sure. So we're MIT licensed for a reason, not by accident. Come on, join us. We actually don't even have some complex contributing markdown file in here on purpose, because we accept, now there is a CLA aspect to it, but we accept contributions regularly. I merge multiple a week, and we strongly encourage it. I will say this, the project is a little bit complex, though now with some AI tools that can make it a little bit easier to grok, if you will. But yeah, by all means, open up a pull request. If you're concerned that the thing you might do is a little bit more complicated, or you want to jam on a design part, join us in the public Slack channel related to that SDK, and the people that work on it, myself and others, literally hop in there and we'll jam on whatever design we have. We do all of our work in the open, very much on purpose. You can literally watch what I do all day.
And then we also got a question from Jason Brown asking, this is a Ruby SDK user, and he heard on a podcast from Maxim that the server is open source, and Temporal expertly tuned its cloud databases so that it can run the Temporal server best. Can that be explained?
Yeah, sure. So I won't get into too much detail because blog posts explain it, and it's not like super proprietary information, though maybe the details are. I don't know. But Temporal is an open source server, and it's very intentionally open source for a lot of reasons, including avoiding vendor lock-in. Right? Let's see. Let's go to it because it's the big repo. Um, but so the server has several persistence engines, Cassandra and Postgres, blah, blah. However, no matter how awesome the database is out there, a specialized database for Temporal's own use can take in certain benefits. But the beauty of a Temporal Cloud offering a specialized database that it uses internally for its multi-tenant setups is that it doesn't have any demonstrable user effect on any of the features. And so when you see a lot of companies trying to, oh, well, we got to differentiate ourselves this way or that way, or we have to gatekeep features, Temporal doesn't think that way. So all features are all the workflow and activity and everything features are available in this open source version and work just fine. But yes, we do have a specialized data layer inside the cloud that helps us optimize for performance, but it is completely opaque to the user because it's a deep down piece. And it is actually quite a novel way to provide cloud differentiation without being forced to gatekeep features, which Temporal does not do.
I think that is very helpful. And Chad, you and I were already talking about this before we started, but I think it'd be great to take a minute and show you're using AI to help you code. And I think it's always interesting to see how other engineers are using it, how it's being applied. Can you talk to a little bit about how you're using it, how it's part of your day to day?
Yeah. So, well, I mean, depends on whether you're asking me now or 3 months ago. But asking me now, I'd say at least 2/3 of my code these days is written by AI tooling. I'm more of a Claude person, but different members of the team use different things. But especially with the recent Opus model, it has helped quite a bit. So, like for instance, we're implementing a new thing called like standalone activities. And these are effectively activities you can start directly from the client. And you may have seen they've already trickled out in a couple of SDKs. We hand wrote it in Python. But I basically told Claude, I was like, okay, look, here's our design docs. Here's the Python implementation and the Go implementation. Let's jam on a design for getting it into C# into .NET. And so we went back and forth. I'm not as trusting as others, so I'm not a pure vibe coder completely. But yeah, I went back and forth with Claude. We got our plan. We did, using the latest Opus model, got our plan together and, went over piece by piece. I won't let it do unfettered work, but I constantly had to rein it in and say, no, you're not thinking right, or no, you're missing tests or whatever. But overall, it saves us a lot of time, especially from a polyglot mindset where the context switching is much easier for it than it is for us. But we at Temporal represent any code we open in a PR as ourselves very intentionally. So this is no different than if I had written it. But the whole standalone activity support in .NET, for instance, was 100% Claude with me constantly at the side with a whip telling it what to do.
We did get a question around AI and asking which LLMs do we find work best, have the most temporal context?
Sure. So I don't have a great answer for that. So I delegate to our AI team. So Temporal, obviously there's lots of interoperability with AI and Temporal. Not only is our Temporal workflows like an extreme superset of agents, and not only does Temporal make running a stable AI better, but there's the aspect that Temporal is effectively a programming model, almost like a programming language, at which point a lot of these AI coding tools can be leveraged to write Temporal. We're working on skills to make that easier. I, off the top of my head, though, couldn't tell you which LLM, benchmark wise, does a better job not accidentally writing non-deterministic code or something. But we're well invested into making them all do so.
And I know we've got some work in progress too to improve upon that. And actually, I'm hoping to do another live stream on that topic in the near future, actually. This is great. I know we're getting close to the 30-minute mark. It goes fast. Chad, what is something you love most about open source?
Well, I kind of mentioned it off the top. I like the extreme transparency. I mean, sure, I have a family of mouths to feed like anybody else, but it is very comforting knowing that the work I do is visible to all. even as I move along in my career, it is very comforting that Temporal's stance on open source gives users comfort. And in general, I appreciate the collaboration because sure, some of us work for big companies and some of us work for small companies. But when it comes to collaborating on things like Temporal or other things, we don't really care. We just see a GitHub username and a contribution and get to all like worldwide collaborate and build on these things. So that's probably the part I appreciate the most.
Nice. Thank you. We have, I think, some good just thanks from the people who've been watching. We appreciate the questions we got. We have Replay, which is our company's conference coming up in May. And if you want to join, there's a code here you can use to get 85% off your ticket. We would love to see you there. If you have other ideas for things you'd like to see us do live stream on or other types of content on, please feel free to reach out, post out into our community channel. As I lose my voice, I'm not even the one who's doing most of the talking. Please post out into the community channel or find us, online. We have a number of different ways in which you can reach out, especially if it's not YouTube or Instagram. And we have this QR code if you want to look at our AI cookbook. You can also search for it for more information around some of the ways in which we're integrating into AI. And if you want to check out our open source GitHub repo, please feel free to go online and check it out. Or if you want to see where to find Chad, you can find him on GitHub. Anything else you wanted to share, Chad, before we wrap it up? This was great. I appreciate you doing this.
No, that's great. Just know, Temporal is not a black box with the public Slack and our completely open MIT licensed nature. We're all out in the open, so don't be a stranger.
Yeah. All right, everybody. Have a good rest of your Thursday, and thanks again, Chad.